Good afternoon. I'm spot on weather meteorologist Matthew Euler, and we're going to take a look at the white Christmas climatology for southeastern Virginia. Oh, how it would be nice to have a Christmas morning, even a Christmas Eve, to look like this. Being a big snow lover myself, I tell you what, I would love to see a picture like this for all of us, Christmas Eve and Christmas morning this year. But let's take a look at some climatology of the past. Let's look at the definition of a white Christmas. A white Christmas is defined as having 1 inch of snow or more on the ground on Christmas morning. And this source is from the National Oceanic and Atmospheric Administration, NOAA. That's where I pulled this definition from. So thanks to NOAA for the definition. So we need at least 1 inch of snow or more on the ground when we all wake up Christmas morning. Let's look at the probability based on climatology. Climate is basically the average weather for a location, the type of weather a specific location typically gets. And so this source is NOAA on this graphic, and it shows you here at the bottom the probability and percentages of a white Christmas. As you would expect, the highest probabilities of a white Christmas are in the northern states, where you have white 91 to 100% chance in northern Minnesota, northern Wisconsin, and the upper peninsula of Michigan. Not too bad, not too far behind that, 76 to 90% chance into central Minnesota, North Dakota, central Wisconsin, up into the higher terrain and elevations of the New England states, out in the mountainous areas in the west. And then you still have a really good shot with these colors of blue, 51% or greater, extending all the way down to northern Kansas, northern Missouri, south central Illinois, south central Indiana, and south central Ohio, in through Pennsylvania, the Appalachian Mountains there in West Virginia, Beckley, those areas in West Virginia. So probability overall for here in Hampton Roads, we're in this gray area. We have a 0 to 10% chance of seeing a white Christmas. Actually, the probability, to be more specific, is at less than 3% for Hampton Roads areas. There have, however, been 6 snowy Christmas days across Hampton Roads, dating back 126 years. So the biggest snowstorm was 2010 in this area, in Hampton Roads area. 14 inches of snow fell. That is quite incredible, considering the odds and the probabilities of that occurring, especially in conjunction with Christmas Day. That's pretty impressive. But before 2010, look at the climatology. You had to go all the way back to 1948 to see any type of snow on Christmas Day. Just under half an inch in 1948. Just over almost 2.5 inches, 2.4 inches in 1947. 0.2 inches in 1917, 1.6 inches in 1914, and only 0.1, basically a trace, of snow in 1902. So, and the source on that is the National Climatic Data Center, so thank you to them for that information. So as you can see, based on the map we just went over, the odds are very slim, the probability is very slim. But some strange things can sometimes happen in the right combination of very cold air, along with storm system tracks, offshore, nor'easter type systems, or even southern route type systems. The two most favorable areas, by the way, for snow in Hampton Roads, you typically have to have a northern stream type of trough, a shortwave trough, and a low pressure system at the surface. It kind of skirts south of the area through Tennessee, North Carolina. The storm track's got to go south of us and then kind of come up the coast from there, pick up some of the moisture off the Atlantic and dump it into southeast Virginia. That happens more frequently, however, that storm track, later in the winter. January, especially February, you typically get snow based on that storm track. And the other track, the more significant snowstorm track, the example 2010 that we got, the 14 inches, that storm track was further offshore of the southeast and mid-Atlantic coast. So I'll show you some favorable factors for snow in Hampton Roads here as we move along. Christmas Day averages. Now, you got Richmond, which is further inland, and then Norfolk here in Hampton Roads, and there's even a Salisbury, Maryland We show you here the average highs and lows. So 50 is average high, and the average low in Norfolk is 34. Okay, and then it just shows you the warmest highs, the warmest averages, the warmest lows, the coldest categories here, the coldest temperatures, 7 degrees down in 1983. It got down to 7 degrees in that year, 1983. The coldest average 83. Look how cold 1983 was. It was quite a year, quite a winter and cold air across the east. Shows you greatest snowfall. It excludes the 2010 snowstorm, by the way. So overall, our snowiest months climatologically are January and February here in Southeast Virginia, when the sea surface temperatures are at their lowest and the air masses are at their coldest. Makes a lot of sense. That's usually the time we get the most. So what are the ingredients for a snowstorm in Southeast Virginia? So there's a big factor here we have to consider that usually prevents big snows from occurring here, and that would be the sea surface temperatures. But let's take a look at the ingredients, some of the charts of a past snowstorm. This actually are charts courtesy of NOAA, NCEP to be a particular case study they did. This is back in 2010. So if I zoom in on what's going on at the surface, there's an area of intense low pressure. This one in this case was 996 millibars, and it is really wrapped up really well, really wound up. Okay, so there's a lot of atmospheric energy aloft that's supporting the surface low. And the track is close enough to Hampton Roads, to Southeast Virginia, but not too far offshore, where all the moisture goes out to sea. Not too close, where you bring back the warm front and it moves inland and snow changes to rain. Basically, this track is perfect in that it's close enough but not too far away to give us a really good lifting mechanism for a good snowstorm. You got cold high pressure as well. That is back to the northwest, ridging into eastern Canada, so cold air is in place at this time. And then looking at the chart here, we're looking at an actual vorticity chart showing vorticity lobes. This is a 500 millibar chart, or a chart at 18,000 feet, and it shows a deep, deep anomalous trough. This is a very cold pocket of air right here, just to our west. And then these little yellow areas here represent vorticity maximum, or areas where the air tends to rise at a greater rate than normal when these pivot around this trough. And then on the lower right here, I have a picture of the jet stream level. And look at the strong jet max that's pivoting in, usually the left front and the right rear quadrants of a strong jet max represented by this red area here, this elongated oval here. That represents areas of the greatest lift in the atmosphere. When you have the cold air is in place again, a deep anomalous trough, straight north to south all the way down into the southern states, and then pivots around back up off the east coast. So this is a perfect example of the things we look at when determining what type of pattern we need for snowstorms. We look at past case studies of big snowstorms to see what was the conditions at the surface low track, okay, and what was the conditions at the 500 millibar level where the vorticity is, a nice cold pocket of air aloft, and then the jet stream as well, the configuration of a jet stream. So let's take a look at the 2010 monster snowstorm, which occurred 24 to 25 December here in Southeast Virginia. And over here, I want to draw your attention. Source is NCEP NOAA for these figures, for the snowfall amounts, but we had 10 to 20 inches of snow over Southeast Virginia into Northeast North Carolina, 24 to 28 December 2010. So that is an impressive snowstorm that we had. It was a white Christmas that year. We had an intensifying low pressure system which moved up the east coast, and that track was in the perfect location, remaining offshore but not too far offshore. Cold air was in place along with moisture from the developing low pressure system. The mesoscale banding. This is another thing that happens typically when you get these really wound up storm systems. You get more of a local scale or mesoscale effect where banding occurs and it brings in a lot of moisture, an anomalous amount of moisture in off the Atlantic Ocean, which just adds to the synoptic scale lifting. And basically it adds greater lifting overall, greater energy in lifting the air. And this results in copious amounts of moisture, especially if you have a band that pivots from east to west over southeast Virginia from the Atlantic. And this happened actually during this snowstorm, which enhanced the snowfall rates. And then you get these convective instability situations and perfect upper level dynamics, which lead to thunder snow, where lightning and thunder accompany the snow. And when you see lightning and it's snowing, or you hear thunder and it's snowing, you are probably getting pretty heavy snow rates of 2 to 3 inches of snow per hour. Just a little bit of instability, vertical cloud development in the winter makes a big difference in snow amounts. This has happened before in the past in southeast Virginia, and it happens a lot too in major storms in the wintertime all the way up to the New England states, as well as convective instability occurs as cold air blows over the warmer Great Lakes areas for lake effect big events. All right, so with all that said, we looked at the probability, we looked at the ideal conditions for a snowstorm in southeast Virginia, some of the charts that we use and look at. What's the Christmas forecast look like for us this year in 2016? And right now it looks like there'll be seasonable temperatures in the 50s and it'll remain dry for southeastern Virginia. It's not looking likely at the present time for a white Christmas this year. By the way, this is the latest model data I pulled in. It's a little bit different from the long range. I just pulled up a long range from this morning and did a video. This is actually a later model run. So we have a 1034 millibar high over eastern Pennsylvania, and it's absolutely dry as that dominates the weather down the eastern seaboard. So it's not looking very likely at the present time for a white Christmas, but that could change. You never know. We definitely have some Arctic air that's been spilling into the area. Again, timing is everything. You have to have the moisture plus the Arctic air masses, very strong cold air masses to overcome the sea surface temperatures to get snow in this area. So that wraps up this video on White Christmas climatology. Again, I certainly hope we get something like this. I'm a big snow lover myself. We went over the definition of White Christmas, the probability, the past years of Christmas Day, which we've had snow in the area. We looked at Christmas Day averages and ingredients for the snowstorm, and a past case snowstorm around Christmas time, 2010 monster snowstorm, dumped up to 14 inches of snow, and then the forecast. So I hope you enjoyed this presentation. I find this stuff very interesting to share with you. We'll keep you updated. Follow us, Spot on Weather. And that wraps up this session. Spot on Weather. If we're not spot on, we're not doing it right. Have a great afternoon.